Okay, well, let's make a start. Hello, I'm Algis Kalukas, and once again, it's my pleasure to welcome one and all to our free monthly virtual What Talks series. For anyone new, WHAT stands for Waterside Hypotheses, Aquatic Theories. Of course, this is only a label, and there are others, but the general idea is that the remarkable physical differences between humans and our nearest relatives in the animal world are best explained by humans having a more aquatic past than theirs. The series started about a year ago on Elaine Morgan's 101st birthday, so it is fitting that today our guest speaker is her son, Gareth. Over the year, we've had some great talks covering many angles that look at human evolution, and all of them have been recorded and are freely available online. Please go to www.whattalks.com for links to all of them, or you can now use the YouTube handle at What Talks, so the at symbol, What Talks, one word, and then you can go directly to the channel. Before they did that, they had this ridiculously cryptic URL that you could never remember. But now, if you just go to the YouTube website and type in at What Talks, you'll get pointed to the channel. So this slot today was originally scheduled to be given by the Canadian paleontologist Kathleen Stewart, who is an expert in unscrambling the sometimes quite scant evidence of fish remains associated with hominin fossil sites. Kathleen published an important paper in JHE in 1994, reporting evidence of the utilization of fish resources at the well-known site of Olduvai Gorge. Unfortunately, Kathleen was unable to do the talk today, and so my first thoughts are with her. I hope she's feeling better and will be willing and able to give a talk for us in the new year. Consequently, it was really kind of Gareth to step in and agree to give his talk at short notice, especially as he is, like me, currently on holiday. It's bizarre to think that normally I'd be in Perth sitting at my office and Gareth would be in Corfu in the warmth, and instead we're both in the cold in England at the same time. And on that note, I must take this opportunity to thank my mate, Paul Stevenson, who I'm currently in his office. So he very kindly let me use his office. Now, Gareth needs no introduction to our regulars, as he's attended and contributed to almost every meeting we've had. I've had the pleasure of being in touch with him a lot over the last 3 years or so, mainly to ask questions about the life of his wonderful mother, Elaine. I was writing a biography about her and a history of the aquatic ape hypothesis for her centenary, and it was a privilege for me that Gareth agreed to write a really great preface to the book, which is now my pride and joy. I think it's fair to describe Gareth as a bit of a maverick, and as he has a reputation for thinking outside the box and for not following established scientific mantras. I've put a potted biography of him on the website, and I'll put some further links on the website later. The range of subjects he's studied and written about is quite remarkable, but today I think his talk is going to be mainly about one of them, which I'll leave him to introduce. Suffice it to say that I think it's a very intriguing idea. It's one that at first seems to contradict what every student of human biology is taught, but it has the critically redeeming feature that it makes a single simple prediction that can quite easily be tested. Hence, Gareth offers us today the tantalizing prospect of overturning one piece of long-held scientific dogma with a properly done bit of science. And if it's true, I think this would add yet another really big smoking gun to an ever-growing list of odd human features that seem to indicate a more aquatic past. So I'm really excited to hear what Gareth's got to say. So over to you, Gareth.
Thanks, Algis. Today is the 13th of November, and it's the 13th What Talk. 13 was my mother's lucky number, so let's hope this goes well. Now, Algis mentioned the smoking gun, and the whole history of the aquatic theory of human evolution reads like a detective novel. It's started going back, as most of us know, to a guy called Wood Jones, and following him, Sir Alistair Hardy, looked at the human body and could see that it had more aquatic features than terrestrial features. Now, this is good circumstantial evidence, but would it stand up in court? Was this proof of anything? So the investigation went on. The circumstantial evidence, the clues, if you like, that a crime had been committed against common sense and against evolutionary science, the subcutaneous fat, the hairlessness, and a few other things that Sir Alistair mentioned. Then along comes Sherlock Holmes, Elaine Morgan. Now, Sherlock Holmes could look at a pocket watch, look at tiny little traces on it, and tell you the whole life story of the person who'd owned the watch. Elaine had the same kind of mind, and from the clues in that Sir Alistair had put in his paper in the New Scientist, she was able to construct a whole scenario of how human evolution must have evolved, including the aquatic face. However, this may be enough to pull somebody in for questioning, but it's not solid enough to stand up in court and arrest somebody for it. And some, I'll just say I'm a little bit controversial at times, and I have annoyed, I know, a number of people by pointing out that a number of things that Sir Alistair and others have called aquatic features are simply not. Some of this evidence was fabricated. That's a strong accusation, but if anybody remembers, and Elaine took it on faith from Sir Alistair, who took it on faith from Wood Jones, that the hair tracts on the human body follow the flow of water, that the hair tracts flow down and in, down across the shoulders and into the spine. But if you have a look, they flow up the spine and out. And if you look at the hair tracts on a newborn baby or even on a fetus, you'll find the hair tracts, for instance, on the forehead go sideways. So that little bit of evidence had to be thrown out. Some other evidence was the dropped larynx and the nose, that I'm saying that there is a very solid alibi to say that those are not necessarily aquatic features at all. Then we started getting some really good evidence that would stand up in court. One was the exostases, the surface ear, and the fossil evidence showed that Neanderthal men also had, mostly the men, also had exostases in the ear. But a good defense lawyer would get that evidence thrown out. Why? Because it's also possible to develop exostases by sitting in a draft or living in a place where there's a lot of cold wind. However, the evidence continued to accumulate, including DNA evidence, which always looks good in court, and just very, it's not a side of biology I know a lot about, but for instance, the genes we have for digesting starches became very significant. Something I've read about just in comments very recently, FADS genes and PUFA genes, I don't know what they mean, but they evidently is DNA evidence that would stand up in court. To me, the smoking gun was the vernix, when we found out that only, because if you take the subcutaneous fat, the defense will say, just because we've got subcutaneous fat like seal doesn't mean we're aquatic, because bears and badgers also have subcutaneous fat, they hibernate. If we take the naked skin, the defense lawyers will throw it out saying, well, the Somalian mole rat is also lacking for but the vernix on newborn babies happens only in aquatic mammals, only, as far as I know, the seal lion, and us. And it has the property of protecting newborn babies against waterborne stomach infections. So that is very much a smoking gun. It's very hard to see how or why such an adaptation would occur if we were not an aquatic mammal. So now from the clues to the evidence to the smoking gun, I'm now going to talk very briefly about a signed confession by the accused. And this is, so I can tell you that the end of the court case would be that we know who did it. It was Homo aquaticus on the beach with a pebble. So my question, being awkward as usual and asking difficult questions, I asked the question, if we were dependent upon marine diet then, if we were coastal dwellers, if we lived by the sea, if what we ate was clams and crabs and fish and seaweed and water birds and all the rest of it, what did we do for fresh water? If we look at the areas of the earth where most of the ancient fossils have been found, they tend to be on the rivers and on the coasts. Now, if we've got time, I want to talk a little bit about drought, which I find that academics and anthropologists find it difficult to understand the concept of no rain. When there's no rain, there's no water, there's no streams, there's no springs, there's no grass, there's no trees. Drought isn't just a hosepipe ban for a few weeks in the summer. A drought lasting 10 to 20 years means there's no water on land. So assuming that we evolved or spent critical periods of our evolution on the coast, where there was only seawater, what did we drink? What did our ancestors drink? And it seemed to me that this would, since at the time it was universally believed that it's impossible to drink seawater in any quantities, and it's certainly impossible to live indefinitely on seawater, then it logically followed we all died. Since we patently didn't all die, then the only way I could see that we could have survived would be by absorbing a certain amount of water through our skin. Now, I started looking into this. If you Google is skin waterproof, I found at least 4 completely convincing, rock-solid pieces of science, some of them contradicting the others, admittedly, but showing that skin is 100% waterproof. But then I thought about the sweat glands. Could we absorb moisture through our pores? I mentioned this possibility to Elaine at one point, but she didn't pick up on it. She was busy with other aspects of it at the time. But then when we were making David Attenborough's radio series, The Waterside Egg, Richard Collins, the producer, came out to stay with us in Corfu, and halfway down a bottle of excellent malt whiskey, this subject cropped up one night, and I suggested quite an easy experiment to see whether this was possible. So one day my wife came home and found me with my hand in a polythene bag full of seawater, taped at the wrist. And she didn't ask me what I was doing, but she said, whatever I was doing, if anybody called around, I had to stop doing it straight away. So anyway, the result of that experiment was that at the end of 3.5 hours, the water in the bag was 10 grams lighter. The only place that 10 grams of water could have gone was into my skin. So this was enough to make it worth exploring further. So the next experiment I did was to borrow a neighbour's bath, because I'd ripped the bath out of our bathroom and installed a shower. So I spent 4 hours in the bath, getting out periodically to weigh myself. And sure enough, in the 3rd and 4th hour of immersion, I gained a measurable amount of weight. And the only place that weight could have come from was the water in the bath. But then came the next question, and I hadn't had a lot of feedback at this time, but there were things I wanted to know. And I'm usually prepared to go to considerable lengths to find the answers to questions that I want to know the answer to. So the question then was, if I absorbed water from seawater in that plastic bag, was I absorbing salty water or was I absorbing fresh water? If I was absorbing salty water, then my kidneys would have to excrete that surplus salt, and my urine would therefore become saltier, denser. If, on the other hand, I was absorbing fresh water somehow from salt water, then my urine would become less dense, would become fresher, less salty. And that was probably the most exciting of the series of experiments, because the results were so spectacular. 4 hours before immersion, I produced, I think it was 89, excuse me a minute, 88 grams of urine, which is barely an egg cup full, because I hadn't been drinking beforehand. So in those 4 hours, I produced only 88 euros of urine. The next 4 hours I spent in the sea, I produced 890, 10-fold increase in urine production. So that was exciting, and I couldn't wait to get home to measure the density. The density of the sample before I went in the water was saltier than seawater. It was at 1,000, and fresh water is 1,000. Seawater is 1,027. My urine was 1,030. During the 4 hours of immersion, the density was only 1,006. So it was very nearly fresh water. So that tells us I wasn't absorbing salt water and having to excrete it. I was absorbing fresh water, somehow through some process of reverse osmosis, extracting it from seawater. Now we know that our sweat glands are capable of reverse osmosis. The water under our skin from which our sweat is drawn is as salty as seawater. The sweat that comes out on our skin is much less salty. It's very close to fresh water. So the purpose of this in evolutionary terms was to preserve our salt supply. Salt is absolutely essential to every part of our metabolism. And our sweat glands ensure that when we sweat, we don't lose a lot of salt. I had contacted various journals about see if they'd be interested in publishing any of this, and I had some very bizarre replies. When I'd originally said, well, this would explain, if we can absorb fresh water from the sea, this could explain how we survived the Miocene drought. First response I got was, there was no Miocene drought. The Miocene era was characterized by large rivers flowing everywhere. There was no drought, there was no water shortage. It was a very wet period. Google disagrees with them. What other replies did I get from them? Oh, obviously the complaint that it was only one subject, and presumably implying I might be the only person on the planet who has this superpower to be able to absorb water from the sea. So, and I guess that's fair enough. Also in science, an experiment has to be repeatable, and it has to be repeated, and it has to be done with numerous subjects. So then I went on and got in touch with various people and got a bunch of volunteers together to do a multiple participant test. Now, I'm going to do this wonderful PowerPoint presentation now. This is Agnos Beach. This is my laboratory on Corfu. This is where I did that 4-hour immersion. And it's also where we carried out the multiple participant experiment. For the purpose, we obtained a portable laboratory. Here's my portable laboratory. And that's where every hour or so, the volunteers would get out of the water, dry themselves, and then they would, using this specialized piece of equipment manufactured specially for the experiment, they would urinate in this device, which would collect the urine. The urine was then stored and labeled for later weighing and density testing. We got one of the staff members from the local university who, with a PhD in mathematics, to supervise the weighing and the measurement of the density of the urine. And this was even more spectacular than before, whereas my urine had a density of 1006. All the volunteers' urine was below 1002. 1001 point doesn't matter, because anything below 1003 in hydrology is classed as fresh water. All my volunteers were peeing fresh spring water, which is a very spectacular result. And this demonstrates something which is completely new to science, and really very exciting. What am I going to talk about now? There was a couple more experiments that I did due to a hormone called aldosterone. Every time I or the other volunteers stood up and came out of the sea standing on our hind legs, our body would have been flooded with a hormone called aldosterone, which is an antidiuretic. And that seemed likely to not only stop urination and the production of urine, conceivably it stopped the water absorption as well. So to answer this one, I did 4 hours of continuous immersion, not getting out every hour, but spending 4 hours continually in the water. And whereas, as I mentioned, in 4 consecutive hours, I produced near enough 1 liter. In the 4 hours continuous, I produced 1.5 liters. Now, aldosterone has got a half-life in the bloodstream of 20 minutes. So that means that after standing up, when we went back in the water, the first 20 minutes, this mechanism for absorption and diuresis would have been suspended. So the fact, 20 minutes is 1/3 of an hour. So the fact that I produced 50% more urine in continuous immersion ties in perfectly with that, and is one of those rare occasions when a scientific experiment conforms exactly to the theory. So that was nice. there was one major more thing I had to consider. And that was, although, as I mentioned, everybody gained weight at different times during the experiment. Overall, from start to finish, from empty bladder to empty bladder, everybody lost weight. So this raised the fearful prospect that maybe the additional fresh water in the urine didn't come through the skin at all, but was actually drawn from our living tissue, that by osmosis, the fresh water in our cells was being drawn out of our bodies into the sea somehow. So we were losing fresh water through the urine. And that means, so if that continued, and we're talking about weight losses of something around £1 an hour, then presumably, if it continued, we'd keep losing weight, we'd keep losing fresh water, we'd become more and more dehydrated until we died of desiccation, even while surrounded by seawater. That was one possible explanation of the weight loss, the rapid weight loss. The other possibility was that this was the body getting rid of reserves of water, unnecessary, unrequired reserves of water. If the body knows it has an unlimited supply of water around itself, it doesn't need to hang on to any internal reserves of water. The camel, 30% of its entire body weight, when it's finished drinking, 30% of his body weight is simply water reserves. We have about the lowest water reserves of any mammal, but nobody knows quite exactly how much it is. But in order to find out, I went for a 6-hour immersion, a continuous 6-hour immersion. Now, I found that I had lost over 4-hour immersion, I had lost about 4 pounds. On a 6-hour immersion, I should have lost 5.5 or something like that if the process continued, but it didn't. Once I got rid of that 4.5 pounds of excess water, which is about 1.5 litres, I stopped losing weight and in fact started gaining it again. So rather than losing 4 pounds like I did in 4 hours, I was only 3.5 pounds lighter. I'd started to regain that weight. So that made it clear. That was the answer I needed to know. That told me what I needed to know. How much reserve water do we carry? And is the water being drawn from our cells, or through the sweat glands and into the urine? And so, yes, I was pretty happy with that. What was I going to say? Now, there were some other experiments that we were talking about doing. One was to prove beyond doubt that water can pass through the skin and be absorbed into the body fluids. There was a proposal to use heavy water, deuterium, hydroxide, deuterium oxide, D2O, deuterium, heavy water, and bathe the skin with that, and then do urine saliva test to show that the radioactive material has passed through to the saliva. However, there was no need to do it because on page 8, this had already been done, not with deuterium, but with tritium, which I think is far more radioactive and probably wouldn't be allowed today. And this was done way back in the 50s. And not only did they show that the water passes through the skin into the body fluids, the tritium was so easy to track that they could see it traveling through the body, slowly into the interstitial fluid, slightly faster through the lymph, and then speeding up quickly when it hits the bloodstream. And also they tested the urine. So we know that water flowing in through the skin does very quickly find its way to the urine. So that was, again, very satisfactory. And although the experiments I've done were limited to 6 hours is the longest one I've done, I found that back in, again, in the 1950s, a chap called Burtner, let me find the reference, in 1959, he did immersing people's hands and feet in water and weighing the socks and everything, very, very long, careful series of experiments. And he found that a human foot exposed to water takes in 1 to 2 grams of water per hour, which is very close to our experiment with a hand in the bag of seawater. And these experiments went on for periods of up to 50 hours. So I think we've now got pretty much everything covered. And I think we can say that with certainty that the human body, while immersed in seawater, can absorb enough fresh water to remain, I'm just going to admit Judy, to remain fully hydrated, and I'm going to say indefinitely. One journal editor quibbled, well, you haven't proved it's indefinite, but the meaning of the word indefinite is nobody can think of any reason why it should stop happening. So I think we've demonstrated that, and I think that is more than a smoking gun. That is a testable hypothesis. It's a falsifiable hypothesis. It's been repeated, it's repeatable, and it's been repeated. And the results are consistent and clear and incontrovertible and cannot mean anything else. Now, the thing with the aquatic theory is that the opponents have got a rock solid objection. And we heard some of this a few weeks back from John Langdon. And the objection is, well, yes, but there may be some other explanation that nobody's thought of yet. Now, you can't argue with that, because you can always say there may be some other explanation for our fat, hairlessness, multipyramidal kidneys, and the long string of aquatic adaptations that we had. There might be some other explanation for bipedalism, which is what he focused on. There might be some other explanation. However, it is stretching credulity to the limit if we're going to say that the ability to absorb fresh water from seawater could have evolved on the savannah, that we could have learned to absorb fresh water from seawater in the jungle, in the forest, in the desert, on the mountain. The other aspect of this, of course, is that our sweat glands, if everywhere in the literature, there's sweat glands are to keep us cool. Now, this could only have been written by academics and anthropologists and physiologists, only by people who've never done a day's work to work up a decent sweat in their life. If they'd ever had a decent sweat, they would know that a thin film of moisture does cool you down very well, provided there's a breeze. If you're sitting in dead calm air with wet skin, nothing happens. And moreover, if you start sweating profusely, and we are capable of sweating up to 2 liters an hour, and if you've ever been in the middle of the day, middle of the afternoon, in the Mediterranean sun, working on the roof with the sun beating down on you, where the sweat is pouring off you to such an extent that the roof is slippery and with danger of sliding off, you will know that copious sweating does not cool you down at all. It is exactly the same as somebody standing by you pouring warm tea over your skin. Pouring warm water over your skin does not cool you down. And that is what copious sweating is doing. The other thing, of course, is that if it was a way of cooling us down, it would be a suicidal maladaptation. Because in places where you sweat that much, it's very dry. Places like the savannah, places like the desert, if you're going to be sweating 2 liters of water, you're also sweating nearly all the salt out of your system. And in less than 3 hours, you can die from hyponatremia, which is lack of salt. If you've seen the people in the marathons, where towards the end, the legs go like rubber, and people have to help them over the finish line, not because their muscles are tired, and not because they've run out of energy. The signals from their brain to their legs do not function because of lack of salt. Salt is essential for those messages to be transmitted. And lovely talk last time from Michael Crawford, who's experienced this for himself. Very, very solitary lesson. He found that within a couple of hours out in the bush in Africa, taking only a pint of water to drink for an outing of several hours, he could barely stand, he could barely walk. If it wasn't for the local people helping him, he would have collapsed. He would have lain there helpless, without water and without salt. End of Michael Crawford. Purely due to sweating. Sweating is a suicidal maladaptation on land. But working the other way, with the water flowing in instead of out, it would enable you to live indefinitely, foraging for food and seawater. Instead of going on to talk about drought, which is clearly a very difficult concept, perhaps now, if anybody's got any questions.
Okay, well, thank you very much, Gareth. If I could start, and then if anyone's got a question, if you can put your hand up and we'll sort of go round whoever wants to go next. I just want to say that it's a really great talk. I love the detective analogy that you went through earlier. That was fantastic. A couple of things. One thing I want to add to this, because I mean, when I heard Gareth talk about this, it kind of rang true with me because my wife and I go snorkeling a lot. And it's just an anecdotal story from myself. But when you're snorkeling for an hour or two, it seems to be the case that you are dying to go to the loo. You know, you need to go for a wee. And of course, if you're in the ocean, you're not really too worried about finding a toilet. But, you know, that's definitely something I experienced. And I spoke to Eric Abrahamson, who was one of the students of Erika Chagatai, and he spends hours in the water studying the Bajau and the Moken people, and he said the same thing. And there's a lovely anecdote, actually. There's a book about swimming by a guy called Howard Means, and in that book he mentions a person that everyone's heard of, Benjamin Franklin, and he had the same experience 150, 200 years ago, whenever it was, and he hypothesized this thing called imbibing pause, which is basically what Gareth is saying. So there's a lot of anecdotal evidence that fits this, and it's absolutely intriguing. And one thing I would like to ask Gareth about is a little bit more, if you could just say a little bit more about the response to this theory, because it is amazing, isn't it, that here we are in 2022 and such a basic fundamental feature of human skin might well have passed under the radar for so long. I mean, this is incredible. All the students that have been taught this, including myself, like Gareth said, you know, skin is waterproof. That's the whole point of skin, right? But this contradicts that. And the beauty of it is it's such a simple thing to test. It's testable, repeatable, all the hallmarks of good science. And so I'm really excited about this. It would be lovely if this could be verified by an independent research group of people, and done in the strictest scientific way and published in a journal of physiology or something like that. But I just want to ask Gareth, what sort of response did you get when you wrote to JHE about this? Because you did quite some research.
Yeah. There's the response. There's the public response and there's the academic response. The public response has been great, and all light bulbs going off everywhere. I've talked to a lot of divers and surfers and swimmers, and they let me into a secret that there is in fact two kinds of divers. There's the divers who pee in their wetsuits, and there are the divers who lie about it. So they all confirm the same experience: copious urination and no thirst, complete lack of thirst. It was spectacular after the multidisciplinary, which incidentally had people of different ages, different sexes, and different ethnicities to get as much breath as we could. But after the immersion, we took them to the mojito bar for a drink of their choice. Now, when we sat down, there was a designer glass bottle of ice cold water with a condensation, bedewed with condensation, and the glass is there to do it. Now, had they been thirsty, this would have been like an oasis in the desert. None of them touched it. They all waited for their ice cream or whatever other things that they'd chosen to order. No sensation of thirst at all. There's also an increasing psychological sense of well-being that intensifies during, as I can give evidence of, those 4 to 6 hours. In the first part of the experiment, where you're in and out of it, you've got to spend another hour in the water. It's so boring. There's nothing to do. You're just walking around, waiting for the time to go so you can do things with bottles and weighing scales and towels. But by the end of the 4th hour, at the end of that first experiment, coming out on land seems so complicated, so difficult, packing things up, getting dressed, loading things up, and just looking back at the water and thinking of just slipping back into that warm, weightless environment. It was so tempting. But anyway, I had things to do and I carried on and did them. I'm sure I've left out lots of bits of it. I do have that quote from Benjamin Franklin, Algiers, that you sent me. He says, this is 1761, and he says there are two kinds of pores in our skin, which we now call eccrine and apocrine. These two kinds. We have imbibing as well as discharging pores. These imbibe, and he says when he goes in the water to swim, however thirsty he was, he's never thirsty for long. He says, these imbibing pores, however, are very fine, perhaps fine enough in filtering to separate salt from water. Hence, I imagine that if people at sea distressed by thirst when their fresh water is unfortunately spent, would make bathing tubs of their empty water casks and filling them with seawater, sit in them an hour or two each day, they might be greatly relieved. Benjamin Franklin knew this 250 years ago. And it's taken that long for anybody to take a look at it and establish that it is in fact true. And it may have come up as an oddity in any other field of research, but the fact that it's come up in connection with paleoanthropology is fortuitous, because it does confirm beyond doubt that, because what I was saying earlier, people say, oh, there may be some, it may have evolved for some other reason. There's no way this could have evolved anywhere else except where there is unlimited supplies of salt and unlimited supplies of water.
Mark, you last week, Mark, you were asking a question with I think with Michael Crawford about this, about how could humans have evolved on the coast. And I think this is potentially the perfect answer to your question. Have you got anything you want to add or ask Gareth about?
Well, comparative evidence suggests that Homo erectus was literal, living along the sea, because he had pachyosteosclerosis, very dense and heavy bones. And Neanderthals were halfway there, which suggests that they lived along the sea, but possibly seasonally followed the rivers inland. They are found here in Belgium, near the Rhine and near the Meuse rivers. And so I think that early Pleistocene Homo erectus was marine, literal, living along the sea. Homo neanderthalensis was halfway, and we are coming on land, living on land. So I wonder, how do these eccrine glands know what they have to do with seawater or with fresh water? What is regulating this? Are the glands themselves, or is it the aldosterone, or I don't know, is the aldosterone working on the eccrine glands themselves? Does this work, this system? I find it spectacular. I never had thought it, but I think you're right. It must be the solution to the problems that we lived, that we only had salt water. It solves my problem. But how did these glands evolve when we first we lived in or next to seawater, and then more to freshwater? We are now living in freshwater. We can't drink seawater. And your studies solve that problem, I think. But I'm still wondering, how exactly did it evolve, and did it when? Is aldosterone working on these eccrine glands? Do you know that?
Okay, go on, Gareth.
It looks like aldosterone is one hormone. It is a antidiuretic, and it contracts the blood vessel. This kicks in when we climb out of the sea. When we go into the sea, a different hormone called atrial natriuretic peptide, ANP, this is a hormone produced in the heart. And this is the exact opposite of aldosterone. ANP increases, is the diuretic. It switches off the aldosterone, and that's why as soon as you go in the water, you need to pee. That's ANP that causes that. ANP also expands the blood vessel. So these two are a switch, and they have an awful lot of other functions as well. And this is a remarkable adaptation. When you go into the water, the ANP switches half a dozen different systems in reverse. When you come out again, those are switched off, a different lot are switched on. And I suspect that which way the sweat glands work is controlled by ANP. However, I'm not going to jump to conclusions. That wouldn't stand up in court, because, and here's one everybody can do in 5 minutes, and why nobody's done it in the last 250 years, you should all be ashamed of yourself. When I was lying in the bath for 4 hours, which is even more boring than being in the sea for 4 hours, I watched my hand dry. Now, if you wash your hands to get the oil off, or any grease or anything, or leave them soak in water for a little while, then watch your hand dry. The areas where there are pores, where there are fingerprints, dry, depending on circumstances, let's say 4 minutes. But look at the creases in your palm and in your fingers. And you'll see that where there are no pores and they still remain shiny and wet. So you can see, you can watch your imbibing pores, your infiltrating eccrine glands doing the absorption right before your very eyes. And then if you turn your hand over, you'll see that the back of your hand, which has fewer sweat glands than the front, will also still be wet. So that was fun. And that's when you can try for yourself. And I'd like you all to do that, please, as homework. And put your comments in below once it gets posted on online.
Thank you, Gareth. I'm just concerned about the time, and particularly Humphrey, because I mistakenly told the people in WA it was a 9 o'clock meeting. Do you want to make a comment, Humphrey? I thought you went on to off mute earlier.
Yeah, so this whole concept probably would be very interesting to the Olympic swimmers. If they gain weight while they're all training, I mean, is that good or bad, or what's the story there? So they might be interested in all this.
Swimmers are interested. We've got a chap on the AAT group who is runs a whole raft of swimming schools right across Europe, and he got excited enough to try it out himself in his own swimming pool. And he said from his own experience, yes, because he spends all day in the pool teaching people to swim. And yes, he had to get out frequently to urinate. And no, he didn't get thirsty. And he did do, fair play, a fairly decent immersion experiment and recorded the results.
Thank you. Has anyone else got a question that you want to ask or make a point? Who hasn't already said something? Somebody who, Francesca, you please.
Well, thank you for your very interesting talk, Gareth. As you know, I've been interested in this from when you first started telling us about it. I've written about it. Yeah, I've written about it in my ongoing work.
Thanks.
And it's very, you know, I found it really fits with the sort of hypothesis I'm developing in a way that if our ancestors at one time were isolated somewhere, cut off from the African continent where there are lakes and rivers and wetland mosaics, if they found themselves somewhere like the Red Sea, which, as Madeline Boehmer has written, went through a period of, the whole Arabian continent went through a period of hyper-aridity during the Pliocene. Basically nothing could cross it. It was just dry desert. If the land bridge over to Africa was cut off, say, by the Zanclean flood, if a small group of human ancestors found themselves stranded on this really long beach by the Red Sea, where there were plenty of seafood options and things to eat, but not a lot to drink because there are not many rivers flowing into the Red Sea, they'd find themselves in a situation where they would basically die very quickly unless they could find a water source. We already, and I've been looking into this a bit as well, and Mark asked, you know, where did this all begin? Well, funnily enough, chimpanzees seem to have about half the number of eccrine glands that we have, whereas other primates, in most terrestrial animals, the ratio is something like 90%, 98% apocrine glands to 2% eccrine glands. In us, it's reversed, it's the other way. We have 99% eccrine glands and only 1% of apocrine glands. But in chimps, it's about 50-50, which suggests that, you know, before that time, eccrine glands were developing in hominoid ancestors, possibly because they were already wetland foragers, or if, you know, if going with that scenario, that, you know, it might be to absorb water, which is something I talked about as well in my talk. Also, I came across a paper that said humans have at least 5 copies of a gene called aquaporin 7, which is a human lineage specific gene on the chromosome 9, I think, or something like that. In comparison, chimpanzees and other apes have only 1 to 3 copies. And it's on one of the most evolutionary dynamic regions of the human genome. The location of the greatest concentration of gene copy number increases. suggesting that this rapid expansion of eccrine glands in humans happened soon after the divergence from chimpanzees. And if that happened, you know, say 5.3 million years ago, when the Zanclean flood cut us off, split chimps and Pan and Homo into two groups, and one group had no access to fresh water, they would very rapidly need to co-adopt these eccrine glands for absorbing water from some other source. And so I think, you know, all of this makes a lot of sense in that scenario.
Okay, Simon, you want to go next?
Yeah, I want to thank Mark very much, because I'm really looking forward to my 4-hour bath. But does it have to be seawater? I wasn't quite clear. You're saying it applies to seawater or freshwater?
Works fine in fresh water. The 4 hours I spent in the bath was fresh water. Warm, by the way, you get chilly after 4 hours. So
Well, that's okay. Well, we can all help with that.
you
The
can.
other question I had was, I didn't note down in my notes how many people did the trial with you, the volunteers.
It was basically 4 participants immersed for 4 consecutive 1-hour sessions and 4 controls on land.
Right, thank you. Thank you.
It's amazing, isn't it? It's amazing, isn't it? Because this could be repeated so easily, and it could be scaled up to the hundreds, and then it would have so much more sort of power statistically. But of course, you know, someone's got to start doing these sort of trial experiments, and incredible for Gareth to have taken all this on and done it. So you deserve full credit. Malgorzata, did you want to speak? You're on mute.
Yeah, I'm unmuted myself. No, really, I don't really, you know, apart from admiring, you know, because I know about the experiment from Gareth, from the preparation to the paper, and I really like it, because all this, you know, the general narration that's human sweating is so good. I see it everywhere. I recently went to a museum in Belgium, you know, the science museum, and it says that, okay, and there is a you know, like an exhibition of all sorts of, I mean, it's a very, very nice exhibition, of course, with all those old cliches that, you know, they got naked to be able to sweat. And it so makes no sense that I'm really surprised why it is repeated. And I really I really appreciate, you know, every bit coming with the proper, you know, proper thinking, so to say, proper Darwinist thinking, evolutionary thinking, not theological. The teleology slips in everywhere. That's really surprising. So thank you very much, Gareth. This is.
Yeah, in the comments, Malgorzata earlier on commented on your term, a suicidal malaptation. Yeah, and that's
Gareth, also, you didn't mention that, I mean, science obviously does know about this, because as you mentioned in one of your earlier papers, there's a billion-dollar industry which gets us to absorb nicotine or hormones and all sorts of things through our skin. So clearly they know about that in some way.
Good point. Good point.
I mean, obviously, all cosmetic, you know, industry. Yeah.
Yeah.
I want to please, Charlotte. I think Charlotte's been to one of our meetings before, but you make the point on the text about women giving birth in water are often immersed in pools for up to 4 hours. Have you got any experience from midwifery about this need to go for a wee if a woman's giving birth in water?
Well, I mean, as a midwife, you know, I've looked after women in labor, and I realize that actually we might be managing these women very, very poorly, because often, you know, we have to make women pass urine, but if they've been in water and laboring, and then they can't pass urine because that's what the body does, not, you know, to this out. I mean, I really have to go back and read my physiology textbooks again. But the other thing that we often find as midwives is vasopressin. That does something else. And I've been retired now, and I've not been with laboring women for a bit. But I think it's really worth me thinking through this to see whether we're actually. And then we also force women to drink water, because they have to keep themselves hydrated while they're laboring. So we might be actually setting them up for some possibly difficult outcomes if we don't really understand this mechanism that Gareth's been talking about.
There's so many interesting aspects of this. I mean, it seems to me there's about 20 PhDs that could be done on the back of this, if only it got a bit of credibility and a little bit of oxygen in the literature. Mark, did you want to say a word? I've noticed you had your hand up a bit earlier on. Another one.
Well, there are two sorts of eccrine glands. They are usually called emotional ecrines, and in the palms and the soles of the palms of the hands and the soles of the feet. And you have the so-called thermoregulatory eccrine glands. So they might be of different functions once. I think we have to consider that also. These thermoregulatory glands, so-called, or possibly sodium regulating or water regulating eccrine glands. But I think we have to make sooner or later the difference between the two sorts. Just a remark. Now I do think this is strongly understudied, an understudied subject that should be studied much more than it is now. Thanks very much for your.
Yeah, I'm certainly going to try and get a cohort of students to do this in the next year or two when I at UWA, because it just seems to me it's a fascinating subject. It would be good if the film, Castaway with Tom Hanks was remade, and instead of having to try and collect all that rainwater, you just lay in the shallows for a few hours. That would completely change that storyline completely. I'm just a bit concerned about the time. Has anyone got any more questions they'd like to make? And then otherwise, I think we'll call it a day. Anyone? One more? No.
I just posted a link to a paper that talks about. Well, you can read it.
The aquaporin thing. Thank you.
Not that one. It's another point that that children growing up in hot water stressed areas seem to develop more eccrine glands than those who live in water plentiful environments. Yeah,
has anyone got any other questions or points to make? Okay, well, in that case, I'm going to call it draw a line under this. Thank you very much, Gareth. That was a really interesting talk, and thanks for your thinking outside the box and not being intimidated like most of us are about being right and following the line in the scientific literature, which is, I think, something. It's very refreshing when you've got the strength of mind to just do these experiments that fly in the face of everything. And really brilliant. So I'm very impressed. So anyway, thank you very much, everybody, for attending. Next month we've got Tom Brenner, I think, talking about vernix caseosa. So that's early in December. I'll be sending a link out to everyone on that, and I'll send a link to the video, which I'm hoping to do. I don't know how I'm going to do this because I'm on holiday. Somehow I'm going to find time to edit the video and post it online sometime in the next 24 hours. All right, well, let's call it a day. Thank you very much, everybody, and it's been an absolute pleasure as always. Thank you. And some really brilliant questions and some really good points, and especially to Gareth. Thank you very much.
Thank you. Thanks, Gareth. Enjoy your holiday.
Thanks for coming.
Enjoy your holidays.
I will.
Bye.